Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and the Kumudini Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in your science class we have been studying about the lesson light. And after our previous class, we learned how to draw ray diagram of image formed by concave mirrors. Yes, and today we are going to learn about the ray diagram formed by ray diagram of image formed by convex mirror. Okay, now see, just like for concave mirror, for convex mirror also there are some set of rules. Okay, now let's start from the starting point. First of all, what you do, you draw a straight line. Okay, you draw a straight line, and from the right end take a random point. Okay, take a random point that would be C. Now notice this, it is just opposite of concave mirror. Okay, it is just opposite of concave mirror. In case of concave mirror, we take it from left. Okay, we take it from left, but in case of convex mirror, we take it from right. Okay, now the at the rightmost point, take a random point which is labeled as C, and then take out your scale. Okay, take out your scale, and exactly at 5 centimeter take another point. Okay, from right side it would be like 15 to 10, isn't it? Or you can rotate this scale as well. If you rotate, it will be something like this. Yes, like this. Okay, you can use scale in rotated position as well. Anyway, okay, so from here exactly at 5 centimeter take another point. Okay, and again at 10 centimeter take another point in the gap of 5 centimeter. That means focal length of this mirror, we are taking it to be 5 centimeter each. Focal length of this mirror is considered to be 5 centimeter. Okay, so the first point you have marked, would be F or focus, and the second point you have marked would be P or pole of mirror. Okay, then after what you do, well, put the compass. Okay, up to that stage it will be something like this. This is gone, or let me just shift it somewhere else. Okay, so what it will be like this, it will look like this. Okay, C, F, P, and then what you do, you take a compass. Okay, my compass is very beautiful. Again, you take a compass and manage it in such a way that its needle is in C. Okay, the needle is in C. Fix the needle in C and fix the pencil in P. Okay, fix the needle in C and fix the pencil in P. Okay, then move your compass, you will get a curved line. Okay, if you move your compass, you will get a curved line exactly at P, isn't it? Understood or not? Now I can remove my compass, or you also can remove your compass. Okay, you understand this or not? Yes. Okay, so this much step is common for all the ray diagrams of convex lens. Okay, so I'm not going to tell you this again about these steps. You have to do it on your own. Okay, now let's discuss the rules. Rule number 1, what happens when light rays are incident parallel to principal axis? Well, in case of concave mirror, they pass through focus, isn't it? But what happens in case of convex mirror? Let's see. This is an incident light ray. Okay, now at this particular point, you can see that the slope of mirror is somewhat like this, isn't it? Slope of mirror is somewhat like this. That means its normal would be like this. Its normal would stay like this. Okay, this be the normal. If this is the normal, then you know that the light ray would reflect to the other side of normal. Okay, the light ray would reflect to the other side of normal. So in case of concave mirror, it would go down like this, it will reflect down, isn't it? But in case of convex mirror, it has to reflect up. Okay, by making the same angle of reflection as the angle of incidence. Okay, by making the same angle of reflection as the angle of same angle of reflection as the angle of incidence. Okay, now we cannot measure the angle each and every time, can we? Well, we cannot measure the angle each and every time. That's why these rules are the shortcuts. Okay, now what you do is, the light ray which is parallel to principal axis, they reflect, that means they go up, yes, but with reference to focus. Okay, if we exactly measure the angles over here and draw, then by back tracing the ray, you will find it that the light ray actually passes through focus. Okay, so in this case, you need to manage your scale like this. Okay, so I keep my anchor point here. Okay, see what I did, I fixed my scale to focus. Okay, I fixed my scale to focus, and then I rotate it to touch exactly at the point of incidence. Understood or not? I fix my scale to focus point, and then I rotate it exactly to touch the point of incidence. Okay, then I need to draw the line in such a way that from focus to point of incidence, it must be dotted line, a dashed line. Okay, and then from point of incidence onward, it must be, I can make it straight. Okay, it must be solid line. Understood? Let's put the scale aside. Do you get it or not? So the light ray, this is incident ray, this is point of incidence. After it strikes the mirror, okay, surface of mirror, it reflects in such a way that it can be traced back to focus. Okay, now you know that we also need to give arrows. Yes, okay, this and this for both of them. Now is it okay? Do you get the rule number 1 or not? When light rays are incident parallel to principal axis, they diverge with reference to focus. Diverge means go away, isn't it? They diverge with reference to focus. Any confusion? Okay, let me put the scale aside. Okay, copy this. Now let's go to rule number 2. In rule number 2 is actually just opposite of rule number 1. If a light ray is passing through, if a light ray is parallel to principal axis, then it diverges with reference to focus. What if a light ray is passing with reference to focus? If a light ray is passing with reference to focus, then it reflects parallel to principal axis. Once again, let me take the scale ruler here. Okay, I have fixed the ruler. To focus. Yes, and then I need to rotate the ruler in any way. Okay, I keep it like this, isn't it? That means if the light ray is incident light ray is traveling like this, keep it straight. just make sure that it traces the ruler. Okay, remove the ruler. Okay. This is your light ray, isn't it? This is your light ray. Need to put an arrow. Okay, this is it. Okay, this is incident ray. Now you know that this incident ray is passing with reference to focus. If the incident ray is passing with reference to focus, if you don't believe me, once again you can check it. See, see, this light ray is passing with reference to focus. Okay, when light ray is passing with reference to focus, in such case the light ray reflects parallel to the principal axis. Okay, any confusion? I hope there is no confusion. Okay, this is the second rule. Okay, this is the second rule, and second rule is just opposite to the first rule. Okay, second rule is just opposite to the first rule. If light ray incident ray is parallel, then reflected ray reflects with respect to focus. If incident ray is passing with reference to focus, then reflected ray is parallel. Okay, okay, that is the second law. Now let's go to third law. Okay, third law is quite simple. Okay, if a light ray is passing with reference to C, what is C? Okay, what is C? Sir, C is female gender of he. Is that right? Okay, maybe that is right in English literature, but here in science, C means center of curvature. Okay, now if the light ray is passing with reference to C, see, like this, so this light ray is passing with reference to C. You can check it by putting your scale, not your scale, actually it is my scale. You do it on your own. Okay, and put your own scale. Okay, so by putting the scale here, you can see the light ray, this light ray, incident ray, is passing with reference to C. And when light ray is passing with reference to C, then it will trace back its own path. Okay, see, this is the incident ray. After it strikes a surface, it will reflect through the same path. Okay, these are the three laws or the three rules you need to use while drawing ray diagram of image formed by convex mirror. Understood? Okay, now we are going to actually draw the ray diagram. Okay, we are actually going to draw the ray diagram today. Okay, in case of convex mirror, we only have two cases. If we remember, in case of concave mirror we have 6 cases, isn't it? But in case of convex mirror you have only 2 cases, because in case of convex mirror, focus and center of curvature lies behind the mirror. Okay, they lie behind the mirror. So what if you put an object at C? What if you put an object at C? Well, the object will be behind the mirror. Okay, and here there is no reflecting surface, so there is no image. Okay, what if you put an object at F, or between F and C, or between P and F, or beyond C? None of them is going to work. Okay, because all of these positions are behind the mirror, and objects placed behind the mirror cannot form image. Okay, so the only place that image can be formed is in front of mirror, and in front of mirror there is no such distinguished position. See, wherever you put the object, it does not matter. Okay, so that is one case. And in front of mirror also you can actually distinguish 2 distinct cases. One, when object is close to mirror. 2, when object is far from mirror. Okay, far from mirror means when object is at infinity, and close to mirror means when object is in front of mirror. We are going to discuss these two cases. Okay, so in number 1 case we are going to discuss about the object at infinity, and as we have already discussed in our previous class also, the light rays which are coming from infinity, are always parallel to the principal axis. Okay, the light rays which are coming from infinity are always parallel to the principal axis. Okay, I need to put an arrow, but make sure that the arrow doesn't kill you. Okay, actually I'm not putting arrow on you, I'm putting arrow on the rays, light rays. Okay, and light rays cannot die. Okay, anyway, if I put an arrow in your chest, then obviously you will die, isn't it? But if I put an arrow on the light rays, they don't die, they are like immortals. Okay, anyway, so these are the light rays coming from far object or object at infinity, and the light rays coming from object at infinity, are always parallel to the principal axis. And according to rule number 1, if the light rays are parallel to principal axis, the light rays will diverge with reference to focus. Okay, I need to shift it little bit downward, I will need some more space. Okay, here now what we need to do, first of all we are going to do it for this first light ray. Okay, so I am going to fix the scale to focus. Okay, I'm going to fix the scale to focus, and then I am going to rotate the scale in such a way that it will touch the point of incidence of first light ray. See, can you place the scale like this? You must be, okay, you must be able to place the scale like this. Okay, this is what you say, a piece of cake in English, in Nepali, बायाँ हातको खेल कस्तो मिल्दैन है piece of cake को नेपालीमा त के हुनु पर्ने हो, यो त केक को टुक्रा हो भन्नु पर्ने हैन र। यहाँ चाहिँ नेपालीलाई इंग्लिशमा ट्रान्सलेट गर्ने हो भने बायाँ हातको खेललाई गेम अफ माई लेफ्ट ह्यान्ड भन्नु पर्ने हैन, but that is not it, है। In English it is called piece of cake, in Nepali we call it बायाँ हातको खेल. These are called the idioms and phrases. Okay, idioms and phrases are the phrases which are popular in particular community in particular sense. Okay, so you cannot simply translate them from one language to another language. Okay, now, and that is a lecture in English, but we are not studying English, we are studying science. Okay, what I'm doing. See, you understand this now? Yes? Okay, that concludes the reflection of first light ray. Now we need to do the same for second light ray. Once again, let me fix the scale to focus point, okay, and then rotate it so that it will touch the point of incidence of second incident ray. Okay, the second incident ray. In that way, what you can do now, okay, from here, from focus to the point of incidence, the light ray must be solid. Okay, the light ray must be solid, and the afterward the light ray will be liquid. No, I said wrong. Yes. Okay, from focus to point of incidence, the light ray will be dotted or dashed, and after that the light ray will be solid. Okay, once again you need to put an arrow on it, and once again it doesn't kill it. Okay, that's it. That's the reflection of second light ray. Now I'm going to reflect the third light ray as well. Once again, the same trick. Fix the scale at focus. Okay, first you fix the scale at focus, yes, and then rotate it. Rotate the scale so that you will touch the point of incidence of third line. Okay, then you need to draw the line the same way, yes, up to point of incidence, dotted line, and beyond that solid line. Okay, let me remove the scale for now. Okay, this line must be dotted. You can use your eraser to make it dotted, isn't it? You can use your eraser. Okay, okay, I do use different tools here. Okay, it is not same like grabbing a pen and simply writing down, not so same. Yes, okay, so this is the reflection of third line. Okay, this is the reflection of third line. Okay, now let us do the same for fourth line as well. Let's fix it. Let's fix a ruler or scale to focus point. Okay, and then rotate it so that it will touch the point of incidence of fourth light ray. Yes, okay, let's draw it. Okay, first, second, and now remove the scale. Okay, put it as, sorry, we need to put it aside. We don't need this scale anymore. Do we? Okay, we might need it later, but for now we are done. Okay, make it dashing and then put an arrow in this reflected light rays. And remember, in ray diagram, arrow is compulsory. If you do not put arrow in ray diagram, then your diagram will be obsolete. Obsolete means incomplete. Okay, you won't get any marks for that. Okay, or you will have to suffer deduction in marks. Okay, this is it. This is a case when the object is at infinity. Okay, now let's go to second case, and I suggest you that you practice these diagrams several times. Okay, because once is not enough. Okay, I guess that is the same motto for Visit Nepal 2020, isn't it? Once is not enough. Okay, visiting Nepal once is not enough. Okay, anyway, saying to the political viewpoint, I guess once is more than enough. If you see the politics of Nepal, just too much dirty, isn't it? The politics of Nepal. Okay, anyway, let's see this is an object which is in front of mirror. Okay, close to it. In first case we discussed about the object placed at far from mirror, and now we are keeping the object close to the mirror. Okay, now let's use the first rule. According to first rule, the light ray, incident ray, is parallel to the principal axis. Okay, incident ray is parallel to the principal axis. Now what you need to do, what we said in rule 1 is the light ray which is parallel to principal axis, it it reflects with reference to focus. Okay, so what you need to do, manage your scale between focus and the point of incidence. Okay, and then draw the line from focus to point of incidence must be dot line, and then after must be solid line. Let's remove it. Okay, so this line must be dotted or dashed, and the reflected ray, this is real light ray, isn't it? The solid light ray means real light ray. Okay, the real light ray must be with an arrow. Okay, you must put an arrow on real light ray. Okay, now instead of rule number 2, I feel it more convenient to use rule number 3. Okay, I feel it more convenient to use rule number 3 because I need to rotate the scale only once. Yes, So to use rule number 3, what I do, I fix the scale to C. Okay, C means center of curvature. Okay, and then I manage the scale. Oh my god, my scale is too short. Okay, if the same thing happens to you, then you have to find a longer scale. But here I have a solution to simply extend it like this. That is not fair, yes? Okay, anyway, by extending it, I know that it touches the object at this point. Okay, so I can simply keep on drawing it like this. Okay, up to mirror, draw it straight line. Okay, because it is passing like this. Okay, and after striking the mirror, it will reflect through the same line. Okay, and you know that these two light rays, reflected light rays, they are never going to meet. That's why you will have to backtrace it. Eventually you will have to backtrace it. Okay, so without removing scale, I would do that at the same time. So this one will be backtraced line, and this one will have a double arrow, because the same one is incident ray and the same one is reflected ray. See, this is the reflection pattern of reflection. Okay, so the first light ray is reflected through this path, second light ray is reflected through this path. Now these two reflected light rays, they are divergent, isn't it? They are divergent means they will never meet to each other. They will never meet. Okay, however, if you backtrace them, they appear to meet at this point. Okay, that's why image will be formed at this very point. Okay, image will be formed at this very point. Understood? Oh my god, what's happening? Okay, I misused the keys over here. Okay, this is the image. You understand it? How is the image formed? Do you get it or not? I hope you get it. Okay, okay, I put aside my scale. You can put it inside your instrument box, geometric box. Okay, now you need to give nature of image. Okay, in case number 1 we forgot to give nature of image. Yes, okay, we'll do that, don't worry. Okay, is this image real or virtual? Definitely it is virtual. Okay, because the image is formed by intersection of backtracing lines. Okay, the image is formed by imaginary lines. And second one, is it erect or inverted? It is erect, because the image is upside up. And it is magnified or diminished. Is the image larger than object or smaller than object? See, in diagram it is smaller than object, that means diminished. Now see, the virtual image created by concave mirror was magnified. Yes, virtual image created by concave mirror was magnified, but virtual image created by convex mirror is diminished. Okay, don't forget that point. Now position of image is between P and F. Image is always formed between P and F. Okay, and in the case number 1, okay, there is no space here. I'm going to write it here. Okay, okay, I simply copied it because the nature of image is same, except for this point, highly diminished, and position of image is exactly at F. Okay, that's why in a convex mirror, object always seem to be within the length, within the focal length. Okay, whatever may be the distance of object in reality, but image always is formed within the focal length, either at focus point or between P and F. That is why when you look at the side mirror of your vehicle, of your bike, car or bus, objects always seem to be near this, objects are much smaller. Okay, objects are much smaller and they never seem to be very far. Okay, although because of size they appear to be far, but actually image is not formed very far. Got it? Okay, anyway, that was the case. Yes, case number 1 when object is at infinity, and case number 2 when object is in front of mirror, close to it. And the next topic, the last topic for today, you know that this is like a question which integrates both the knowledge of concave lens and concave mirror and convex mirror. A concave mirror is also known as converging mirror, and a convex mirror is also known as diverging mirror. Why? The answer is, in case of concave mirror, if incident rays are parallel beam, then reflected rays are convergent beam. Okay, it converts parallel beam into convergent beam. That's why it is converging mirror. Very simple. Yes, it converts parallel beam into convergent beam. You know convergent beam, isn't it? Okay, that's why it is converging mirror. In case of convex mirror, it converts parallel beam into divergent beam. See, the incident rays are parallel beam and the reflected rays are divergent beam. Okay, that is why this mirror, the convex mirror, is known as divergent mirror or diverging mirror. Okay, see, a concave mirror is also known as converging mirror, or you can also write convergent mirror. Okay, in some cases slash convergent, same, they have same meaning. Yeah. Okay, a concave mirror is also known as converging or convergent mirror because when parallel beam of light rays are incident on it, the rays are reflected so that they all merge at focus, so the reflected rays form converging beam. Any confusion? Okay, next, a convex mirror is also known as diverging or divergent mirror because when parallel beam of light rays are incident on it, the rays are reflected so that they appear to diverge from focus, so the reflected rays form diverging beam. That much. And while answering this question, these two diagrams are compulsory. Sir, diagram नबनाए पनि हुँदैन भनेर नसोध्नु. या चाहिँ सर डायग्राम बनाउनु पर्छ कि पर्दैन भनेर पनि नसोध्नु. Okay, you have to draw it. है, किनभने डायग्राम बनाउनु पर्छ कि पर्दैन, पर्छ भनेर सोध्नुको मतलब त्यो मलाई थाहा छ डायग्राम बनाउनु पर्छ भनेर, तर सरले चाहिँ बाई एनी चान्स पर्दैन भन्नु होला कि भन्ने एउटा ग्लिम होप मात्रै हो. है, okay, so let's not go over there. Okay, draw the diagram. This is physics, and particular this is light chapter. Okay, and we are under the topic of ray diagram. The topic name is diagram, so you have to draw a diagram. Okay, that's it for today. I hope you will practice all these ray diagrams at least 4 or 5 times. That's the only way to master it. Okay, until then, goodbye class. Thank you class.